Okay, I'm going to get started a little early here because we have a lot to pack into today with the quiz coming up tomorrow. I'll just let you know, I know it's Wednesday. If I get to the interview, I get to it. Okay, if not, we'll do it on Friday. All right, because I got a review for the quiz, go over homework, and then start the new stuff that's not on the quiz. All right, so we got a packed class today. All right, let's review for the quiz tomorrow. I will be after today if you want to come by. Also, on Aspen, under the circle folder, Unit 10 on Aspen, posted there are arc length and circumference questions, practice questions if you want them with answers. All right, so you don't have to come to me and say, can you send me this? Arc length and circumference questions are on there. Speaking of circumference, let's do this. Circumference is equal to two formulas going into tomorrow that we should know. I'm not going to have too much patience here. 27 pi d, or we can go 2 pi r. Yep. All right, up here, I have angle ABC. B is the center. B is the center. How do I find ABC, or what do I call ABC, angle ABC here? All right, either one you can give me right now. How do you find it, what it's equal to, or what's its name? Here we go. All right, I'm done. Okay, here we go. 5. Either one. What's its name, or how do I find it? It's called the central angle. Nice. Central angle is always equal to, let's roll 6. The arc measure. In this case, arc AC. Everybody good? Measure should be in degrees. Anytime I ask for the measure, should be in degrees. If I wanted to find the actual length of an arc, you have 2 options tomorrow, one in degrees, one in radians. I've said this so many times. Know both or know one and be able to convert. Okay, know both or know one and be able to convert from radians to degrees. The one in degrees is equal to, if the central angle is in degrees, what's the formula? 13. That you're thinking about converting. I don't want to convert. So I'm just going to put measure here over 360 times circumference. All right, if the angle's in radians, new formula, another one. Here you go, 6. S equals theta r. S is for the arc length. Theta is your central angle in radians, and r is your radius value. All right, everyone good there? Okay, speaking of converting, you will have a formula sheet attached to your quiz tomorrow. How do I go from degrees to radians? And I know it's so easy just to say, well, it's on the formula sheet. I don't need to worry about it. But yeah, there's 2 on the formula sheet. You got to know which one to pick. All right, so it is still important, even though I'm going to give it to you. How do I go from degrees to radians? Multiply by, oh, okay, I don't have to pick anybody. Sure, pi over 180. And then if I want to go in reverse, if I have radians and I want to turn it into degrees so I can use the other formula, I'll multiply by 180 over pi, so the pi's can cancel out. Good so far. Still packing it in here. We got a lot more. Finish this statement. A diameter perpendicular to a chord. Diameter perpendicular to a chord. What's happening? 16. Bisects the chord. If I give you, or a piece of a diameter, remember, I'm probably not going to give you the full diameter, but piece of a diameter perpendicular to a chord bisects the chord. All right, what if 2 chords are equidistant from the center? All right, if I have chords that are the same distance from the center, what should I know? Finish that statement. 26. They are congruent. The chords are congruent. All good. I'm giving away everything here for tomorrow because I'm not going to give you a hint on this next one. If you're using a clock, how many degrees are in 1 minute? 6 degrees. That's not going to be a hint tomorrow like it was on your homework. Okay, and I'll say how, you go from 1 to 9, how many radians, how many degrees did you go there? Okay, 1 minute, 6 degrees. And I put this one on because I didn't think it was fair if I didn't tell you. Wheels and revolutions. I don't have anything, I'm a math teacher, and I don't have anything circular. in this entire room? Okay, I guess I'll use the metal. It's not really what I need for purpose-wise. That's not magnetic. Okay, here's my circular metal. All right, if I put it on Meg's desk here and I roll it 1 revolution, I want to know what the distance is. And you know the diameter. Okay, so here's my metal. I don't know, it has a diameter of, 8 inches. If I roll it 1 complete revolution, I want to know how far it went. What do I need to find here? Okay, if I want to know right now, if I roll it 1 complete revolution around, I roll that, and I want to know how far on her desk it went. What am I really asking for here? Just the circumference, okay? So from this distance here all the way around, that's the same as saying if I rolled it 1 revolution, the circumference, okay? So I just wanted to run that by you, so I didn't think it was fair to put that on and not talk about it, okay? Okay, so I rolled it twice, so it'd be your circumference times 2, okay? Or how many revolutions in 1,000 feet? Then I'd find the circumference and take 1,000 and divide it by the circumference. All right. That's on the extra problems too, on Aspen, problems like that I put on there. Okay. Homework for tonight is due on Friday. Okay. If you want to focus on the quiz, you can do that. So what we go over today is not on the quiz, and the homework will be due Friday. Okay. Because I don't want to check it tomorrow and waste time. All right, put that bad boy back there. That bad boy. All right, so that's all I had as far as the quiz tomorrow. Anything you want to ask there before I go to last night's homework, 1 algebra, 2 proofs? Because I told you I didn't post the answer key because I wanted to see what you guys had. Anything for tomorrow? You'll get a formula sheet, but it's only got the conversions on it. That's it. All right, moving on. Homework, here you go. Here was the first one. Wanted to see what you got. I didn't want to post the answer. Wanted to see you guys work it out. We good here? I'm going to call a number here. Yeah? No? 16? No, you don't have to come up, Emma. Just, what'd you get? 13.7, yep. How? Okay, ready? Where else can you put in 86? Oh, come on. Start using some vocab for me. Not this one. This one is 86, yep. Just your geometry knowledge, no circle knowledge. What's the relationship between those two? Supplementary, so I have 94 for that. All right? Good so far. X is a what in the circle? Radius, so is this one right here, which makes that what type of triangle? Isosceles triangle, right? So the angles across from them are also congruent, so the 43 and 43. And now, I don't know you guys, I use a lot of sines on this one. All right, I said 20 over sine of 94. I'm sure there's other ways you could do it. Probably not cosines, though. And then x over sine of 43. Good there, Meg? Anybody, we good there? And then your proofs. Just tell me what you got. Throw a statement and a reason out at me, please. Okay, I had to prove the triangle's congruent, so I won't waste time writing down everything, but I'll go over all the different ways. So tell me one thing you wrote in your proof and why. 7, one thing you wrote in your proof and why. Say that again. Okay, DA congruent to CB, that's true. Why? Arches? What are arches? You got feet here?
Arcs.
Congruent arcs imply congruent chords. Perfect. So I got 2 chords congruent. What else you got for me here? 3. What else you got in your proof? Whew, yes, they are. You can put that all in one statement. All 4 are congruent. Because in a circle, make sure please have in a circle, remember, all radii congruent by itself. Not true in a circle. We could stop right there. Those triangles are congruent by what method? Side, side, side. Did anybody go ahead and say angle DOA is congruent to angle COB? Congruent arcs imply congruent central angles. You can do that. Side, angle, side. Okay, side, angle, side. Any other method I'm missing there? Going? Okay, no proof on there tomorrow. No proof. There's just, look, it's either going to be this or it's going to be this at this point in the unit. I can't give you anything different. You don't have more facts yet. Okay, the proofs will get a little bit more difficult, all right? So I'm not going to throw one up that is going to be, you know, oh, side, 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 and I'm done. All right, that's a waste of both our time. All right, how'd you get the 2 triangles congruent? Had to get the 2 triangles so I could do a little CPCTC at the end. All right, how'd you get them congruent? Here you go, 8. What do you got for me? Why are they right angles, Colin? So perpendicular lines form right angles? Yes. Thank you. All right, 23. I got right angles. Where do I go next? You first tell me the right angles, then you tell me they're congruent. Perfect. All right, keep waiting here. 24, go ahead. Not here, garbage. 27. Because of? Thanks. All right, you guys left the tougher one for last here for somebody. 11, want to pick that up? Oh, nice, huh? 5. Okay, I am going to write this down here. AC bisects EF. I don't know, with me going crazy yesterday in class, if I drove home that point or not, but if you want to use this theorem, diameter perpendicular to a chord bisects the chord. This theorem does not say the 2 little pieces are equal. It says the chord gets bisected. Please use it properly. Now, if you wanted to say EW and WF are congruent, what do you got for me? Definition of a bisector. Good. What? Now name the reason the 2 triangles are congruent. Here you go. 16. Why are they congruent? Side, angle, side, and then we end this thing with CPCTC. All good. Questions? Anything here? Ready for tomorrow then, because that's it. What we're about to do today, not on the quiz. Going? Okay. Good deal then. We're all set to go for tomorrow. Can I see what you did, please? Just real quick. I know it was only 3 and we just went over them, but I want to make sure you get the credit you deserve. It's okay. All righty, here we go. A new type of angle. This is why I get so fired up when somebody just calls it an angle and not a central angle, because you're going to learn about a different type of angle inside the circle called the central angle. Somebody remind me, a central angle, where's the vertex? It's got to be the center. Well, it doesn't have to be the center and still be an angle inside the circle. So everyone put a point on the circle for me, please. On the circle, on the circumference of the circle. How about that? And I want the two rays of your angle to be chords. Okay, so you shouldn't stop here and draw the other one here. Make the 2 sides of your angle chords. That's disgusting. This is now an inscribed angle. okay, where the vertex is on the circle and the two sides are chords. All right, so you can label them with whatever letters you'd like right now. Everyone see the difference between an inscribed versus a central. Don't draw it on your paper, but take a look. Everyone see an inscribed now and a central angle. Here's my central. It's equal to what? Arc AC. Here's my inscribed. You don't know what that's equal to yet. All right. Next circle, draw a diameter in for me. Draw a diameter in. Just want you to be aware of a different way. I could draw this inscribed angle and then draw a chord to it. So the vertex is still on the circle. That's still an inscribed angle. That is still an inscribed angle. So what's the deal? How do I find the measure of it? Because it's not equal to its arc. But pretty close. Inscribed angle is equal to half the arc measure. So half its arc measure. All right, so these facts are starting to pile up on you. Central is what? Equal to its arc. Inscribed, half its arc. Half its arc. All right, so quickly go to the second diagram that you have. For me anyway, angle E. How would you find angle E then? For me, and then you can write your own, whatever you put in your own letters on your diagram. It'd be half of arc DF. Yeah, okay? Half of arc DF. A lot goes with this. A lot goes with this inscribed angle. Everyone okay? Any questions you want to ask? All right. All right, let's try one out then. Here's a triangle I put inside the circle. It's inscribed. I gave you the 80 for angle A, and I gave you the arc measure of 88 for arc AC. Find some other stuff for me. Let's start with arc BC. Arc BC. First of all, does segment BC go through the center? No, so that's not a semicircle. All right, it's not a typo either. All right, it's not a diameter, so that's not a semicircle, so I can't say 180. But take a look. Is there an angle up there? Name the angle that's drawn to arc BC. Name the angle up there that's drawn to arc BC. Angle A. Everyone see, angle A is drawn to arc BC. And what type of angle is A? Inscribed, because take a look, the vertex is on this circle. So this is inscribed, and usually to find it, I take half of the arc. I would take half of the arc to find 80. So to go in reverse, what do you want me to do here? 13 thoughts. There you go. All right, so BC will be 80 times 2. Are we okay on why we're not taking half of it? To find the angle, you take half of the arc. So that's 160. I always like to get in this habit. Always, once we find a piece of the diagram, start labeling it yourself, because we may need it later on down the road. Angle B. 21. What type of angle is angle B? Do we have a 21? Inscribed angle. We just found out the fact is you take half its arc. What arc is drawn from? What arc is created from angle B? 18. What arc belongs to angle B? AC, which is 88. I'm going to take half of 88. Oh, not again. 44 degrees. Okay, 44. I'm just ignoring. Angle C. You don't have to use a circle fact here. Angle C. Angle C. 25. Any thoughts for angle C? God. Killing the momentum. 28.
Oh, I added 80 and
Okay, 180 degrees in a triangle, everybody. 56 degrees. And then finally, the remaining arc AB. A couple different ways you could get there. I just want to know one of the ways. How do you get there? 25, no. Good job. 5, how we getting there? Yep, we can multiply 56 by 2, or you could take the two arcs you already have, add them up, and subtract from 360 degrees in a circle. Yep, and that'll give me what there, Ella? 112 degrees. How do we feel here with the inscribed so far? Okay, all right, we'll see. We'll see how you feel. All right. This is where I lose a lot of kids because they do not like all the chords flying in that circle. Okay, it's very hard to take a look at. You have seen nothing yet. All right, if this bothers you, we're going to have some issues down the line. All right, so find arc A, the measure of A and angle B there. All right, no problem. So let's start with A. Just so you know, A is the same as arc PT. Arc PT is A, what we're looking for. All right, so everyone search in the circle now. Is there an angle that's drawn to arc PT? Can you find an angle drawn to arc PT? Because angles and arcs are associated somehow. 6, find any angle that's drawn to PT. P something. PQT, yes. I don't want to deal with this angle because I don't know anything about those type of angles, but this angle's a what? What type of angle is this angle here? PQT. It's inscribed. I know the relationship between inscribed and its arc. Hey, if you're going to look at this angle, I don't know what that relationship is yet anyway. You will down the line, but not today. All right, so I'm going to take that 60 and multiply it by 2 to find the arc. So the arc there is 120. And then what about angle B? Identify it. Is it ready? Here are our two choices. Is it central? No. Is it inscribed? Okay, yes. So now I say to myself, to find an inscribed angle, I take half an arc. It's your job to figure out what arc does it belong to. So highlight it, whatever you have to do, go with your hands. Here's angle PRS. Boom. What arc does it belong to? Name this arc. PTS. Everyone see how it belongs to that arc, P to T to S. How large is that arc? $1.50. 120 plus 30. Half of $1.50, 75 degrees. Questions from there, you guys? I'm going to let you take a quick breather here because this box is going to be a new theorem. Yeah. Anything on the inscribed so far? Equal to half its arc. I'm going to show you a new theorem with inscribed angles right now. Okay, somewhere around here in the box near it, I need you to draw a circle for me. Draw a circle, put a center in that bad boy. You don't need to name the center in this case. Please draw in a chord AD for me. Draw in chord AD. And then I would like you to draw in chord CE that intersects AD. CE. And they intersect at point B. And then I'd like you to connect AE and CD together. So you should have something that looks like this. So you form two triangles. I'm going to give you guys about 30 seconds in your group. Find any pairs of angles that are congruent. Find any pairs of angles that are congruent. And be able to back yourself up. Any angles in the triangles you can find that are congruent. Okay, I'll steal a group's thunder here. Yeah, the vertical angles are congruent. Congratulations. Anybody find any others other than the verticals? Are there any other pairs up there other than the verticals? Or did you thought, or were those the only pair? Hi, Maggie. So E and D. So we have a proposition on the table that says angle E is congruent to angle D. What type of angle is E? Inscribed. Name the arc it's drawn to. What type of angle is D? And what arc is it drawn to? So aren't you going to be taking half of the same arc? So aren't these going to be congruent? Any others up there? Orion. A and C are what type of angles? And they're both drawn to which arc? ED. Here's your new theorem. What type of angle? I'll go back to Maggie's. E and D, what type of angles were they? Inscribed angles. And what'd you know about those inscribed angles? Well, before I even got there. Where were they drawn to? Same arc. Inscribed angles drawn to the same arc are, what did we just find out? Congruent. Yes, that can go into a reasons column of a proof now. Even a more challenged question. What do I know about the two triangles? Watch your mouth. Similar, not congruent, similar. By what method? Angle, angle. All right. Kids know something. All right. Anything else we want to talk about? Because I got more facts about inscribed angles. Two more actually coming at you. Two more. Let's go. Here we go. I will let you and your group figure this one out. Find X, Y, and the measure of arc BC. All right, so you and your group discuss it, do some calculations. Find X, find Y, and the measure of arc BC. Get after it. Ask yourself, what type of angle is it? It's either going to be central or inscribed. What do I do from there? There's still some confusion, which is good. You guys are talking it through. Let's start with X. Is it a central? I'm going to say this every time. Get used to it the rest of the unit. Is it a central angle? No. Is it inscribed? Yes. So then I say to myself, all right, if it's inscribed, I'm going to take half of something. So I have to identify what arc it's drawn to. And if I draw out angle X, does everybody see it is drawn to this arc AB? Okay, but I didn't label it for you. I didn't tell you the measure because I didn't need to. What is AB in the diagram? A diameter, so this arc is called a semicircle. What is the measure? 180. Okay, it's 180 degrees. I didn't need to throw that on the diagram. So if I'm going to find X, which is an inscribed angle, I'm going to take half of 180, and that'll be equal to 90 degrees. And that is that's the third theorem for today. You don't have to write it down because it's already in the box here. Bottom line, inscribed angle drawn to a semicircle is a what? Right angle, okay? So we can use that in a proof now. An inscribed angle drawn to a semicircle is a right angle, okay? Some of you now, how can I find y? Well, central angle. Inscribed. Yes, so I would be taking half of what arc? It would be half of BC. I have no idea what BC is, and nor am I going to find it either. But what is ABC here? It's a triangle. You already know that's 90. I got the 58 was given to me, so 180 minus 90 minus that 58. And we end up with 32 degrees. Got that? See that? Now I could find arc BC because you just told me that central angle was 32 degrees. Inscribed angle was 32 degrees. What do you want me to do with it to find its arc? Now I'll ask one of you kiddos. 18. Double it. What do you got there, Caitlin? 64 degrees. Recap time. Oh, we're not ready yet. We're not ready for that last one. How do you find an inscribed angle? Half its arc. If I have two inscribed angles and they're drawn to the same arc, they're congruent. If I have an inscribed angle drawn to a semicircle, it's a right angle, 90 degrees. One last theorem about inscribed angles. It's literally the last one. Like, you couldn't just wait. I don't care. I'm just so fired up right now. Are we ready? Curtains. Clock. Flip. Shatter. Genie. The fact that I take time out every time to vote on what the next slide is going to be is unbelievable. Curl. Slide right. Slide left. Star. Spin. Drop. Fade. Pinwheels. All right, here we go. Promethean man or the star? Ready? Here we go. So we get to this last problem. This is a big homework too. Promethean man or star? Let's go. It was clock it is. Sorry. All right, here we go. So you two clocks. Congrats. Way to go. Way to go. Nobody listened, though. Nobody listened. All right, here we go. One more theorem to go over. Part A is not that new theorem. You go right ahead in your groups right now. Find arc GFE for me. GFE. That is not a new theorem. You already know how to find that from today. Find GFE for me. Follow the letters. See if there's an angle drawn to it. All right, what are we doing to find arc GFE? 3. What are we doing to find arc GFE? Doubling the inscribed angle that's drawn to it, which is 86. And what do we end up with there? 172 degrees. All right, so GFE is 172 degrees. Now I want to find angle F. What type of angle is F? Let's go through this. What type of angle? Inscribed, right? So I should be taking half of which arc? GDE. Is it possible to find that measure of GDE? Well, you just found the other part, 172. What's the relationship here? 172, what are you going to do with it to find this arc? Subtract it from 360. And I hope this comes out to be 94 degrees, which it does. Now I know I mentioned that there's a new theorem here. I didn't want to give it to you, but you found it. First of all, what is EDGF? 4 sides, I call it a quadrilateral. And it's what do we call this if all the vertices touch the circle? Inscribed. So if you have a quadrilateral inscribed in a circle, what do you know about its opposite angles? 86 and 94, what do they add up to? 180. And if you turn back, this is risky. Don't do it to me. Come on, I just want to finish class. Thank you. All right. Quadrilateral inscribed in a circle, the opposite angles are supplementary. That's the 4th theorem right here. Okay? Yes? Yes. I'm good, thanks. I'm good. All right. Homework's due on Friday. You guys will come in. I'll take any extra questions you have, and we'll start the quiz. Good session.